Section 5.6, example 24, using the root test. So for each of the following series, use a root test to determine whether the series converges or diverges. So with the root test, what we're looking at is some value rho, and that's going to be equal to the limit as n approaches infinity. We're taking a big, huge root to the power n of our sequence of the absolute value of a sub n. And it would make sense right here because we're taking that root of n. All right, so let's go ahead and get started here. So again, we're letting rho equal the limit as n approaches infinity of the nth root of this value here. So I'm going to write it under one root. So it's the absolute value of n squared plus 3n over 4n squared plus 5. And here. So now all of these values are positive, so we can automatically get rid of the absolute values. The nth root tells us to take the nth root here. So this is equal to the limit as n approaches infinity of n squared plus 3n over 4n squared plus 5. So that's going to be equal to the limit as n approaches. I'm going to divide both top and bottom by n squared. So we have 1 plus 3 over n over 4 plus 5 over n squared. So this ends up going to 1/4. And based on the root test, 1/4 is less than 1. And because 1/4, or because rho is less than 1, this tells us that we converge continuously. So converge, not continuously, converge absolutely. So therefore, converge absolutely. That was easy. Let's see if the other one's as easy. Oh. Bring it up here. All right, so we're taking the limit as n approaches infinity of the nth root of n to the power n over natural log of n to the power n. So nth root all the way through. And we have the limit as n approaches infinity of n over ln of n. All right, so we could apply L'Hopital's rule. We have infinity over infinity. So we have the limit as n approaches, and we could do L'Hopital. So we have 1 over n, which ends up being the limit, forgot infinity, the limit as n approaches infinity of just n, which goes to infinity. So therefore, this series diverges. So sad, but the series diverges. And that's it. If you have any questions, please feel free to ask. Otherwise, bye.